we can make a throwing. It's a throwing bottle opener. Well, it's a multi-purpose tool, and it can be used to be thrown to. Here we have a sample.
Oh yeah, that's the famous JoJo bottle opener.
Let me ask something. There's people from other channels asking if they can see the live stream. So if they can drop for me a link, that's all gonna drop for them. Pedro.
Welcome.
Pedro is recording too. Now we have two cameras.
Yeah.
Camarada.
Hi, Pedro.
So, he said hi to you. Falou aí pra você.
Oh, hi.
Yeah, because I'm wearing phones, so you could not listen. Well,
I've been running two here and there. I get my air now. To speak here.
let me light the forge because it's not lighted yet. So let's produce small charcoal. What is better, this way or that way? I believe that way is better. It gains more area. Bota na geladeira. Let me connect to the power. Yeah, power connected. Yeah, you speak.
Ask a question there. In the past, you talked about meteors and alloyed steel alloyed in space.
Yeah.
And, yeah. Did you see the meteors that I posted in the chat room there?
No, I didn't saw. I'm gonna take a look in a few moments. Yeah. I'm just gonna light that, and I'm gonna take a look. I have meteorite blades. One of the blades that I have to finish, it's meteorite done. Very expensive. It's like very, very expensive. Now it's gonna be fast to light the forge because it's a very dry day. The charcoal is very dry, so it's gonna be very easy. Very, very easy. Just a few moments and we're gonna start to count. Well, where is everybody? Let's call these people. Besides, I want us to discuss curious and strange things and conspiracy theories, all that kind of thing. Isso, pega a cadeira aí, pega a cadeira aí. Bota aqui. Aí estão saindo os preços das damascos. Chato da Ford é ligar a Ford, né? What sucks by the Forge is to turn on the Forge. It sucks. It takes a while, a few moments. There we go. Yeah, much better now. Let's put some power. Yeah, now it's burning wild.
Well, looks like it's gonna be kind of a slow day here.
Yeah, I am seeing that. Well, I sent the video shot to my room, so probably some folks are gonna appear by. But anyway, the fire is good. It's burning hot. So let's forge.
Okay.
Isso vai feder. É uma parada que eu já tinha que ter queimado há muito tempo. É. Cabelos humanos.
How do you make your steel? How do you make your steel so hard?
Oh, it's not exactly hard. It has memory form, so it deforms itself, but it conforms again. So it gets much less harmed than if it was hard. That it was. So, because of memory form, it doesn't need to, be hard. It's gonna flex, move, and then gets back to its original shape. That's why they are. Hello, Critical. How are you? Bem-vindos.
So,
Hello, Michelle.
based on what you said, it gets hard upon impact, right?
Repeat, please. I didn't get it.
According to what you said, it gets harder upon impact.
Yeah, when you strike it, or when suffers any type of heat, or if you pass too much electrons at it, like electricity running through, then it's gonna remember the shape. And anytime that we hit something, great parts of the synaptics, because it's the movements we're gonna stop sudden. Great parts of that kinetics pass through energetical phase, and it becomes heat. It becomes sound, heat, and other types of noise per se. And when it becomes heat, not only heat, the kinetics itself, it's going to provoke the material to get back to its original shape. So even if it do like a little bit like this, it has the ability to get back like this. And that's how real Damascus is supposed to work. That's why it's so expensive, even the fake Damascus. And the real Damascus, like these ones that even behave like ancient Damascus, are a little bit more expensive. Well, I proportionate it not so expensive for my clients, but normally it's much more expensive. So I hope you enjoy it. The same formula that I use for the Damascus, we're going to use for that bottle openers that I'm going to make by live stream, one out from these. So, what?
Are you forging a bottle opener?
Yeah, I'm going to forge a bottle opener because it's, it's not too rush for me, and also I have it's the type of artifact that it's easy to sell. It's very easy to sell. So it's the type of artifact that definitely it's very good. It's very nice to forge for a live stream. Yeah. So first step, let's hit the freaking bar.
Do you quench? Do you quench the metal?
Tem uma internet
Water
nova.
quench.
Tem a internet da colina. Causa da colina, a senha é felicidade.
Yeah. I didn't understand what you said.
Sorry, I could not understand. I'll need you to repeat. Sorry.
Well, I was asking about quenching. Water quench, air quench, oil quench.
Oh, doesn't matter. Yeah, I can water quench or oil quench that, or even air quench. It depends if it has the presence of the bacteria.
We're having some trouble here on my end with the video. It's frozen.
Diogo, você tá mutado.
Valeu. É, porque a internet tá indo e voltando, tá uma merda. So, for that tool made out of rebar, I can water quench it, and if there's the bacteria in presence of in my quenching bath, it's gonna work perfectly, and after done, I'm gonna be able to puncture through steel even. It's crazy. And it's just a rebar too.
Yeah, the one is there. Must be the raining. Come back to Rio de Janeiro.
That's step one. The very first step to take.
What temperature?
What?
What is the temperature of the steel that you work when you're working on the forge? On the anvil? How hot is it?
How hot? Depends. Now I work it under about 800 Celsius degrees. 800, and but soon when I finish to align that's two ends, I'm gonna work at 1,300 Celsius degrees, and then I'm gonna weld forge that. Oh, let me just see one thing.
Red red hot is 800. White hot for forging for the weld is 1,000 for welding.
Yeah, 1.3 thousand approximately, because it has too low carbon. So the welding point is very high up. It's very near the melting point. And I don't use flux. I don't use borax, anything like this. I work only with the things that the material itself can offer to me. Então, eu estou explicando que eu não trabalho com borax, eu não trabalho com nada disso, né? Eu trabalho apenas com aquilo que o material é capaz de suprir para mim, entendeu? Então eu tenho que trabalhar em temperaturas extremamente altas. So, now explaining in Portuguese for Brazilian or Portuguese audiences too, or people in Macau, I don't know.
What is case hardening? I hear about case hardened steel. What is that?
Oh, I don't know if I know. What's the name again?
It's in English case, CASE, case hardening.
Oh, case hardening. It's when you doesn't let too much space for exchanging temperature. You have small places to quench it, and it gives a marvelous hardness, but becomes brittle. That's what is case tempering, exactly. And it has two types of case tempering. That it's case tempering with the material inside a box case, and also case tempering that the tempering tank it's so thin that it provokes the same effect. So now I'm gonna stretch the two sides, the two legs. I'm gonna stretch them together. You know, it's like this. I'm gonna make this. Doesn't need to be all freaking aligned because it's just don't need. We are dealing with a rebar that it's considerably thick. So because of that reason, we can
you move your camera down a little bit to the anvil?
Yeah. If I can, sorry, repeat. Put this.
Yeah, that so I can see what's happening with the anvil.
Yeah. Oh, okay. Let me put it at a better place. Just a second.
Sorry to interrupt you. Yeah,
oh, no problem. Now it's better. Wow, the cell phone can fall. Just a second. Let me put in a better way. Just a second. Aí tem outra cadeira para você, pega ali. Não, aí fica alto demais. Fica alto demais. Deixa. Ah, achei. Tá aqui. Pronto. Prontinho. Agora sim. Opa. Yeah. Ok. Não é para trás que pode cair, não, é para frente. É. Fica relax, não adianta. Well, I believe that's the best I can do with the equipment I have. But it's better, right? Tell me. Então ficou melhor a imagem?
Yeah, that's a better angle.
Yeah, much better. So now let's hit it here and make it. Now we're gonna weld forge it.
What kind of fuel are you burning in your forge?
What?
What kind of fuel are you burning in your forge?
Oh, it's a soft wood charcoal. It's not even hardwood. It's soft wood charcoal. It's spinous. But if you do everything right, you can smelt steel here with only that poor energy charcoal. It's poor energy, but we don't need too much energy. We need the exact amount of energy, you know. There's too much sound. Can you hear my voice even with the whole forging sounds? Dá para me escutar direitinho mesmo com todo o som da forja? Vocês estão me ouvindo?
Tô lhe ouvindo.
Oh, perfect. Now we should reach 1,250 to 1,300 almost Celsius degrees in order to weld forge these, to make a weld forge without the needing of electricity or electric forge. So let's burn these.
A qualidade da imagem está muito boa agora.
Tá boa a qualidade da imagem? Excelente.
Tá.
Yeah, that's cool. So now I'm burning the steel and waiting for the signal. This steel signalizes when he's ready to be worked, depending on every work you're gonna do. Now the work is to weld forge it. So we are now waiting it to be perfect to be weld forged. I'm gonna put more energy here because the weld forging, as I said, demands more energy. So we need to reach a certain quantum, a certain amount of energy to guarantee a real good weld forge. And we need a real good weld forge because the exactly place that we are forge welding is the exactly place that's going to be the tip that must be resistant enough to do loads of freaking hard tasks. you know. So it's deeply important that. As you can see, here we are around 900 Celsius degrees. But it's too cold yet. Now I put it by the most violent parts of the fire. And we're gonna wait for the metal to signalize. There you go. Now it's just a matter of time. For us to have the desired effect happening. Então, galera, se vocês quiserem trocar ideia, vocês podem trocar ideia também. É uma live de teoria da conspiração também. Apenas é bilingual. It's a conspiracy series live too, but just bilingual, Portuguese and English.
These bottle opener are also very nice, aren't they?
Fala em português, eu traduzo.
Ah, beleza, vai. Então esses abridores de garrafa, eles também são homenagem a Vinícius.
Sim, exatamente. Yeah, they are. Well, there you go. We are having some signals from the forge. So I'm gonna just turn a little bit that and wait for more signals coming that it's arriving. And now I'm gonna weld forge that. Let's weld forge it. All right, it's properly weld forged with a sound weld forge. This is a really sound forge. Sound welding. This is what I call a sound welding. Right? So let's clean a little bit. And let's plunge it again. You see how it doesn't deform too much? It's just welded, just that. With even less deformations that if I were using an electric arc forge, for example, an electric arc machine, for example. The only thing is, now I'm gonna do a little bit more of hot forging by the exact tip, just to assure that it's gonna weld perfectly and we're gonna retain a resistance, an amazing resistance, the resistance of two vectors and not only one vector of pressure per se. Então, essa parte é a parte muito física da coisa, né? A gente vai criando um ponto de sustentação, que é a ponta dela, que é composta por duas arestas mestras, né? Que na verdade são uma reta. A gente dobra, faz um círculo, do círculo a gente faz, né, um artefato, né, uma forma que lembra muito um Ankh, né, que lembra o Ankh egípcio, e por aí a gente vai fazendo a coisa. Então, um Ankh, ela lembra um Ankh egípcio. Todos esses símbolos antigos, eles são geralmente derivados de coisas que são forjadas.
triângulo, tudo isso.
Sim, tudo isso sai da forja. São as formas, cubo, são as formas que você é obrigado a trabalhar na forja para você depois fazer formas que são abstratas. Só que a abstração antes sai de uma geometria. Primeiro você cria a geometria, depois você faz a abstração.
Ó, falam que o antes, ele é o símbolo que inaugura o conceito de uma chave. Muitos existirem chaves.
Exatamente. Porque, na verdade, as primeiras chaves eram feitas assim, né? É exatamente isso que eu estou fazendo. Se você quiser fazer uma chave daí, você forja uma chave daí. As chaves de castelo eram feitas assim.
Aqui é que a tudo visualmente para abrir o portal do mundo dos mortos. É uma chave.
I'm gonna put a little bit more energy for the reasons that I spoke before. Então estamos colocando um pouquinho mais de energia. Remembering that you're gonna make beads.
Diego, ainda no assunto sobre as chaves, em que momento que as chaves começaram a ser fundidas e não forjadas?
Não teve um momento específico, esse momento específico é local.
Estou entendendo.
A mesma coisa que aquela história da idade do aço, idade do ferro, idade do bronze, isso daí não existe como foi ensinado às pessoas que existiu.
É exatamente o que eu queria estudar. Exatamente o que eu queria estudar.
Exatamente. So, there you go. We have a perfect weld and we have a lever to make turns. I'm gonna just put that more pointy a little bit because we're gonna need that a little bit more pointy, and then I'm gonna finish to make the circumference that it's not so circumferic. It's more ellipsoid. It's more an ellipsoid. And after the turnings, after some forgings, it's gonna be properly done. And after treated, it's gonna have quite impressive abilities.
Diogo, esse molde em cruz que você pegou de vergalhão, é ele que vai fazer a volta na ponta do abridor de garrafa?
Entendeu?
Esse vergalhão que você pegou, que é em forma de cruz, que você botou o abridor de garrafa, a ponta do abridor de garrafa nele, é ele que vai fazer aquela volta no abridor de garrafa, certo?
Não, ele faz a volta depois da ponta. Ou antes, dá para voltear independente da ponta. A ponta vai me ajudar a rosquear nessa maquininha de rosquear que eu tenho. por causa da medida do vergalhão. Entendeu? Porque tem vergalhão que é mais fino que é um saco, que aí eu rosqueio ele antes de caldear.
Ah, tá. Eu pensei que você botava a pontinha dele ali dentro para afinar.
Não. Põe não. É na porrada que eu afino. Que é o que eu tô fazendo aqui agora. Now I'm shaping it to make it able to be turned. And there we go. And let's take a look at here. All right, it enters. But I do believe I have another one that we're gonna be better. Let me find. Tem que achar uma outra dessa aqui, que é maior. Tem ideia de onde está aí, Pedro? Dá uma olhada aí. Aqui não tá. I'm gonna find the other one that it's bigger and it's better. Não, cara, eu tô procurando uma cruzeta dessa, cara. É maior que essa. Então não pode ser pequeno. Just a second, guys. I'm just looking for a tool that should be here, but it's not. It's here. If it's not too big, probably it's too big. I'm gonna need to use a small one. Yeah, it's too big. It's too big. It's too big. So I'm gonna use the smaller because this one is too big. So in order to use that smaller one with safety, I'm gonna need to spread that a little bit more. Então eu vou usar a pequena mesmo para essa medida aqui. E para eu conseguir usar com segurança total, eu vou achatar um pouquinho mais. E aí, galera, o que vocês acharam da live de ontem? Now I'm asking to some friends what they thought about my live stream yesterday for Brazil. That it was about frequencies and blood apoptosis. A very different issue than the issue we are dealing here. Guys, you can say anything you want, and we can talk about other issues too. Então, vocês estão livres para falar, a gente pode conversar sobre qualquer assunto. Não é porque eu tô preso na... fala.
What do you think about this news with the gravity drive in drones? Have you seen any of that?
No, gravity drives? No.
Yeah. Anti-gravity drives.
Oh, anti-gravity, yeah. Well, I never truly saw anything that annulates gravity, but, you know, you can use other forces to temporarily burn the gravity effect. For example, if you make a triangle or a delta with aluminum foil, you don't need to make too much folds, just one, and you energize. You make a tripod and you energize two places of the tripod. You, depending on frequency, voltage, and power that you input, so you make it float. You literally make it float. Or the effect when you induce very hard metals and they float, they become inducted and floating to the point they melt, or to the point they reach the austenitic phase and they cannot be anymore magnetized. That is the case of iron and steel. But with some metals like aluminum, you can make it float till it melts and falls, for example. That's the most near anti-gravity that I experienced or even saw. Like super ceramics, for example. It's not anti-gravity, but resembles it. To avoid the gravity effect, it's something that would need probably a massive body being being contrasted with a very tiny body, and then for sure you can generate a line that can produce the effects of a secondary gravity working over the primarily gravity of the planet, but it's not anti-gravity. It's just an illusion created by the achievement of a great big mass body being confronted very near with a tiny body that works more like a point in space than a tri-dimensional body, depending on the scale we are speaking. That's my answer. Now, let's turn that shit. Okay. Okay. Yeah. Now we're gonna put that thing here. Let me just put it by the perfect. Okay. It's gonna be here. Yeah. All right. Let me move the camera for you guys to see. Okay. Yeah, you guys are going to be able to see exactly what I'm going to do. So let's move that here. I'm going to invert the piece. Just cool its head because I need it with the coolest head possible. And let's give a load of heat. Então agora a gente vai fazer o curl, né? A gente vai fazer a curva ali, na verdade a torção, né? Uma torção, não uma curva. Vamos fazer a torção. E no final dessa torção, a gente já vai ter grande parte do corpo do artefato pronto. Depois a gente só tem que forjar alguns detalhes, tudo mais. Aí tem que forjar a cabeça, forjar o clipe, e aí fica tudo perfeito. Então agora a gente vai usar aqui. So now we're gonna use hair. I truly need that very hot. Eu realmente preciso disso bastante quente. Ele tem que ser torcido o mais quente possível. É por isso que, geralmente, quem gosta de trabalhar com torções, eu sou um dos ferreiros que adoro torção, para várias coisas. Então, a gente tem essa morsa perto da forja, né? Antes eu tinha que ir na morsa lá de dentro, dava certo, mas eu não saco. O correto é ter essa morcinha aqui. Então aqui eu já vou separar a cruzeta. Tá bastante quente. It's so freaking hot. So it's time for us. Yeah. Done here. I'm gonna put that very fast here, just to correct the curvature and to correct it all. I don't need to be preoccupied upon smashing the material because the material will gonna be mashed anyway. So that's the final form, and now we're going to strike here these sides. So we did 1, 2, 3 folds. I can do another fold or leave it with a nice bigger neck. I'm going to make it with a nicer bigger neck, and for that particular artifact I'm forging here for the live stream. Now we're gonna work the head.
Esse processo que você faz quando sai do fogo para girar o abridor tem que ser bem rápido, né? E o ferro esfria rapidinho.
É, e se ele esfriar rápido demais, você vai rasgando o ferro. Ele vai arrebentando. Entendeu? Ele tem que estar super quente. E ele realmente esfria muito rápido.
Eu não tinha visto isso de perto. Agora que eu vi.
É. Essa é a parte mais chatinha, mais crítica, assim. Mais chato que só o caldeamento da ponta mesmo. Por isso que eu já faço logo de cara. And that artifact, we're gonna be, if anyone wants that one or other ones, it's up to sell, to be sold. This one is nice because you guys are gonna have the whole panorama of how to forge it. Okay. So there you go. Our nice long neck. And now just a bit more here. So it's yeah. Yeah.
Can you talk a little more about austenitics?
What?
Austenite. Can you talk a little more?
The austenite phase is when the material become non-magnetic at all, even if it's a ferromagnetic material. That's the austenitic phase. When we speak about the allotropic curve phase of metals, specifically speaking about carbon steel constructs. So now it's fitted. Now I'm gonna work from here to here. Let's start with the very tip because I'm gonna make a very pointy tip. Então vamos começar a trabalhar agora ali na pontinha. Vou fazer uma pontinha super afiadinha. Eu vou forjar ela o mais rapidinho possível. Now it's by the exact place that I need. Now, to ensure that the forge weld got well. And I know that got well because I turned the whole material and anything delaminated. So I know already it's good, but doesn't matter. I need to make a point, a tip. I need to make a tip. So in order to do that tip, I'm gonna need to work fast because it's very hot here. So I'm gonna unite the kneading and the perfection. So I'm gonna work that by near the welding temperature, and when I do so, I'm gonna assure that it's gonna be even better. The welding and the final tip. Because remember, we want a tip that can armor pierce things. O que é? Vai comer. Acho que você já tinha vindo almoçado, cara. Deu mole, porra. Como é que você vem pra uma parada depois do almoço sem almoçar? We are almost there. All right, we have the temperature, and I'm gonna forge it. Okay, and now I'm gonna work the very, very tip at very high temperature because I want that tip to not fall apart by any means. Deu mole. Não. Agora a gente está esquentando mais a pontinha e eu vou trabalhar só a pontinha mesmo. Eu vou trabalhar em temperatura de caldeamento. Ela já está na temperatura de caldeamento. Eu só estou esperando a dispersão máxima de íons, pegar o martelo e pronto. Agora vocês têm. Now you can be certain that it's impossible, because of that explosion you saw, it's impossible to delaminate it. Now it all became the same thing.
Tem que começar a sair, para começar a caldear direito.
É.
E isso é quente pra caralho.
É, isso é quente pra caralho. É o momento que o ferro e o carbono começam a se soltar. E o ferro queima. E o ferro literalmente queima fora.
Nesse momento começa a acontecer a migração de liga?
Oi? E nesse momento acontece migração de carbono. Aí, através da migração de carbono aguda, você tem o fenômeno do caldeamento. Do caldeamento pleno. Né? Que é o sound welding. Como é dito em inglês. Entendeu? Então, tá aqui, ó. Now we have the material all welded into only one, and I can assure that tip is the most resistant part, the most potential, because you need how to treat it. Otherwise, the point will naturally be the last resistant part of your whole artifact. So that's very important to know. Now I can work the tip. I can work the tip under below 900 degrees and above 700 degrees. Then after the steel become smooth, very smooth, then I'm going to be able to forge it at almost room temperature. And when you do that, you give the last density to its crystals. And you prepare it, when treated, to produce the higher quality crystals that you can have and achieve. So now, yeah.
We're over an hour now.
Okay.
Maybe you want to ask the room, does anybody have any questions or comments?
Yeah, exactly. So, galera, temos uma hora. So, folks, we are forging for an hour. I believe that now it's the moment if you want to make more questions and anything, and if you want to, and also if we stop the show now or if we finish these artifacts, well, it's by the end of the forging of these artifacts, so it's not gonna take much longer to finish it.
Diogo,
Oi.
Qual a conexão do material que será tornado esse abridor com, por exemplo, a conspiração de Roswell?
What's the connection of the material that you're gonna be, of the artifacts that is being forged right now with the Roswell conspiracy? That's a real good question. Well, the connection is The Roswell conspiracy was to maintain under the radar patents, well, secrets that were then after turned into patents by United States and Russia, and secrets that were collected by Germans back then. So these material were going to be treated to have memory form, quite like the special materials that permeate the Roswell conspiracy. Well, the Roswell conspiracy, the alien part is fakery, but the material part is 100% real. And the connection between them both is that I'm going to use here a formula, a treatment formula, that makes that material have a small quantity of the behavior that the material from Roswell naturally presents by the configuration of its materials that make them. So that's the connection. It's a huge connection. It's really a big connection. It's not a small connection. We are speaking about something huge here. Answered? Respondido? Now, now just a little bit more heating, and this piece will gonna be perfectly done. I asked for only 20 minutes of forging just to finish that artifact and test it, because I believe people are gonna love to see, even by a more than 1 hour live stream. I do believe when you share, people are gonna love this.
Joe, outra coisa.
Fala.
Esses abridores, eles são tratados em um trio 36 antigo, não é?
Exatamente.
Tá.
Dizem que as agências de lugares, elas são na verdade, todas as patentes aí hoje em dia.
O Pedro tá aí?
Oi?
Pedro tá aí?
Pedro tá aqui, ó.
Ó o careca. E aí, Pedro, beleza? Esse teu malho tem algum tratamento, Diogo? Além de têmpera?
Tem sim. Não, ele tem têmpera, ele é super têmpera.
Ah, tá, super têmpera.
Ele é super, exatamente.
Ele quica.
Os modernos nem temperados são. Você que tem que temperar.
Eu tava vendo uns novos. Falando isso.
Eu comprei uns novos, são uma merda. Da Tramontina. Tramontina não tempera mais eles, não.
Tramontina já foi bom.
Já. Bom, a Tramontina agora é...
De fato, tudo feito na China. Saudade da época que o facão deles era aço 1070.
Exatamente.
Você não sabe, eu cheguei a comprar um facão Tramontina sendo que era 1070 ainda, em 2020.
E qual é o aço? Sabe qual é o? Eu não sei.
Não faço ideia, eu sei que é um aço de menor carbono.
Que bosta, hein?
É, uma merda.
Bom, eles seguiram a recomendação do Mitril de reduzir o carbono, mas eles não têm Mitril, ficou uma merda.
Não serve pra nada.
So, now I am making all geometrically accurate. And now I just need more one heat to finish the very tip. And 1, 2, 3, 4, maybe 6 heats to finish the whole thing. 6 to 10 heats to finish the thing, the whole artifact. And how it's going to now, what you guys are thinking about the design and everything, tell me. E aí, o que vocês estão achando do design, de tudo até agora, do trabalho?
Eu adorei a pontinha, cara. E achei super harmonioso também.
Yeah, say it, bro.
Yeah, one side of your hammer is flat, the other side is round. What are the uses that? What does the round part do? What does the flat part do?
You're gonna see the flat part do what I did till now, and the round part you're gonna see in a few moments. I'm gonna show to you. I'm gonna not need to tell you. I'm gonna show to you, and you're gonna love it. Okay, for the tip we have already enough energy. Just a few more adjustments. Yeah. Yeah. Oh, yeah.
Jojo.
Yeah, you can speak.
Yeah. What about hearing loss? I'm not wearing ear protection.
Sorry, repeat, please.
What about hearing loss from blacksmithing? The noise. The noise. Does this hurt your hearing? You lose your hearing from noise. The banging.
Oh, yeah, it's normal. It's the noises of the place. You know, it's me working in that piece and has people working in other things too, very nearby here by the other workshop places that I have. So that's why you're gonna listen all these polluted sounds and everything. Well, I believe that I just need to tap here and tap here, and it's gonna be very symmetric. Just one more tap here, and one more tap here, and one more tap here, and here, 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 here. Ta 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 ta. Yeah, symmetric.
Oh, that's amazing, Jojo. You're
That's
very
amazing.
talented.
Beautiful. That's beautiful. Beautiful.
You see, the end here, it's exactly as the end here. Exactly this. Exactly.
Simétrico espelhado.
This.
Symmetric and mirrored. And mirrored.
And
Perfect symmetric.
this side to this side. See? Very pointy, very, very pointy, and a perfect pyramid. Now, we're gonna give a hit here to not disturb this place. I'm gonna quench it. Okay, it's quenched. So I can even hold from here. Okay, here is very hot, very, very hot. But here I can hold
Agora vai
it.
usar a parte redonda do martelo.
Yeah. Now, in a few moments, we're gonna see how the round parts of the hammer will gonna work. So let's hit that a little bit, and let's work to finish that artifact, to finish that piece. And it's gonna be a very beautiful piece. And we have dark beer here that I bought it just to test out that beautiful bottle opener that can be thrown by the neck of other motherfuckers. It can be used as a punch dagger too. So it's very versatile. My forge is with the cold dumping, so I need to undump the core and grab the very tip, bring here, and burn it. Now it's in a good place. Now I don't need too much heat because I want the metal to deform one over the other, but not get stuck. It must have some movement, because when I throw the blade, if the blade doesn't go with the tip where I want, I don't want the blade flying around. I want some of the energy to be stopped and the blade to clank and fall the nearest possible the place I thrown. So for that reason, we're going to use we're going to use elastic potentials to do that work. So here is our beauty. I'm going to work the cross section here, where one cross to the other. And I'm going to just pay attention to the thickness, because I want the maximum thickness with exactly the same thickness of the original material, the original rebar. So I must work with some attention here and use the strikes that deform to one side to conform to the other side. So it's a deformation conformation battle, what I'm doing here. So there we go. We just need to do an effort here. Let me see. Perfect. Another effort here. I use it now, the round part, to create more pressure. To create more pressure under one specific point, so I can deform by the exact amount that I need to deform to make it to be evenly beautiful. Now I'm gonna need to reheat everything and give the final works. The tip, I'm gonna down the tip a little bit. Yeah, the tip down it a little bit. It's got perfect. And I just need to work a belly that is here. By the sound, the belly, yeah, by the very sound, the belly has no more. And yes, the belly has no more. Now just one more heat. And we're gonna work the final detail, the very final detail at the head of the artifacts. And I believe that probably I'm gonna even forge here and forge here, or don't. No, I'm not gonna do that. Just let me take a look at this bottle. Yeah, first time that I measured, and it's perfect. Just perfect. Pode. Just perfect. So let me take a look at the profile of it. If the profile suits me, then I'm gonna finish in only more 2 or 4 heatings. I just need to see if the profile will gonna serve me. Yeah, it's beautiful. It's beautiful. The tip is so pointy. The tip's so freaking pointy that I had to choose if I was feeling the hot or if I was feeling the hurt. Just more. Oh my gosh, I just need to. Yeah. Okay. Yeah, the thickness is all right. Let's finish that. Now you're gonna see for what that exists. I'm gonna show you right now. Let's burn these.
Well, Jojo, this bottle opener is a starting project for all your students.
Yes, this is a project that I designed. That's my design for my students to follow. And this is the type of projects to have fast money. Because, for example, in the United States, an opener like this, it's like $35. So it's the type of things that if you forge people and show how to use it, people are gonna love it. You know, it's that kind of material, that kind of artifact. Now we're gonna use a deformed hammer because we know it's soft, and that part here. And we're gonna draw the clip of the bottle opener. It's not still hot enough. It's not hot enough. So let's heat a little bit more because we need that plenty hot.
What will you be doing for the next video, Jojo?
The next short talk. Oh, take a look at that. I'm gonna put it down here, and I'm gonna put this here, and now we how like Thor. Mjolnir! We still got heat. Yeah. See?
Yep.
But it's not finished yet. I'm gonna need one more. No, it's not heated properly. Let's heat it properly. it's properly heated, now we're going to make a beautiful drop to make a beautiful heart. Now we have a beautiful heart made out from a beautiful drop by the top of the heart. And now we invert. And with my grandfather's hammer, I just put everything lined. Yeah, my great father, in fact. And there you go. Finish it. Finalizado, ele forma coraçãozinho bonitinho, perfeitinho. It forms a heart too, if you can see.
Uma encontrando a outra. Também.
Também. Aí é só amassar aqui em cima também.
Pedro falou o quê?
2 serpentes, igual um caducil.
Caraca, mas é meio que isso.
And let's try. Yeah, it's working. It's working properly. And now I'm gonna treat it to have memory form, and for us to be able to throw it against very hard, even walls, and don't happen anything bad to it. So let me just give the final adjustments. We have a final adjustment here. We have a final adjustment here. We have a final adjustment here. Here. And we have a final adjustment here. And for a 35 USD artifact, it's pretty good. Don't need to be better than this. Yeah, just one more here. Yeah.
Esse aí até o Drácula fica com medo.
Exactly. Yeah. Done. Just, it's so hard. Você derrubou meu celular, tá, Pedro? Só pra te avisar, você tem que começar a prestar atenção, cara. Aí tu quebra meu celular aí, fode meu bagulho. Porra, presta atenção aí, caralho. Porra.
Porra, Pedro.
Sai de perto da porra do celular, é só não ficar perto dessa merda.
Tá no foco? Tá no foco?
Mexe não. Deixa do jeito que tiver. Tá melhor do que no chão. A última mexida que você deu, ele foi pro chão.
Dá pra ver de boa, não precisa mexer não.
Ai, caralho, é muito chato fazer esse último. It's
What were all those final
Mas
adjustments
esse
for?
último. Yeah, the final adjustments is to make it completely straight and finish it, because after I treat it, it's gonna be the final shape it's gonna have. And the next procedure, we're gonna be treating. Agora sim. Now it's good. Now it's good. Yeah. Yeah, it's well aligned. I like it. It don't need to be so perfect. It's hand forged. Pega lá, meu maninho. Pega que nós vamos usar já já.
Using your cell phone for the live stream?
What?
Are you using your cell phone for your live stream, Victor?
Yes, I'm using.
Seems pretty good. What is that?
Yeah.
5G? 5G?
No, 4G, but today the connection's perfect. Ah, obrigado. agora mesmo que cai bem. Você acertou, André. Don't take me bad. This piece is freaking hot still.
E dá pra pegar, se não der, mano. Tá com a marca aí. Meu Deus. Será que dá?
Yeah, it's striking and puncturing my anvil with the final color. That's the final color from the forge. Beautiful, huh?
Ô, Diogo, ela tá meio dourada?
Uh-huh.
Oxi.
So now I'm gonna make the tip very tippy, and let's test it. I'm gonna make the tip tippy! Tippy!
Yippee!
I am here, guys! Finished. So let me change a little bit. Yeah, there we go, guys. Yeah. The first test. So let's see if that shit works.
Function.
Works, and not only that, you can put the it's here, and you can do that and close it again. Well, I'm not with so steady hands, but you saw it. It worked. Now let's. Oh my. Yeah.
Can I get?
No. Fuck. Nothing happened. Can you see the tip?
You got it. Great. Go.
This is steel. Now let's test if it's a good throwing blade. So
They're better than the other.
much better than the other. This one, it's...
And this is worst.
Vai, sai daí.
Worst.
Vai para trás.
Again.
Let's try it again. Aí você tá na frente da outra câmera, Pedro. Sai pro lado. Não precisa ir colar a bunda lá não, é só sair da frente da porra da imagem.
Não, já fiz. Já fiz as duas. As duas são melhor ainda.
This is how it's meant to be used. But not only that way throwing, you can use it as a, oh fuck, as a punch dagger too. So let's throw it. Fala, Crispim, beleza?
Fala, Crispim!
So let's throw it very well here. Yeah. I'm gonna make a very hard throw and see if I can move the whole block. Yeah. 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 Yeah, motherfuckers. Yeah, motherfuckers. Yeah.
Traz pra câmera ver.
Aqui, ó.
Bring it here.
Another test.
Jesus.
Continue. The same position. Again.
Tirou o crossfit.
That's video.
You can make CrossFit classes with it. Last one, and let's end the live stream. So,
Oh, yes.
thank you so much for your presence, guys. You saw how to finish to end forge these, and well, we must also remember that, let me invert the camera. For example, this is natural stone. Can you see the sparks?
Muito que a imagem tá ruim.
And another thing, this is also a hammer. It wounds the steel. See? It's wounding the steel. Nothing to do with the bottle opener, but it wounds it.
Well, that would definitely be a welcome addition to every man cave.
Exactly. You can do loads of creepy things and nice things with this. Oh, punch dagger function, as I told you. Imagine punch someone in the face with that crap. And that's for the Today Show of Hindu Orion forgery, because this is legitimate Hindu Orion forging.